Hello all, welcome to this class on projection of solids, and in this class let's solve a problem on a pentagonal pyramid. That is, the problem is a pentagonal pyramid 25 mm side of base and 50 mm axis length rests on HP on one of its corners of the base such that the two base edges containing the corner on which it rests makes equal inclinations with HP. Full stop. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. So let's try to solve this problem. The first thing what we'll have to do it is draw the XY line. So I mean that's very common, as you know, in every problem. So let's try to do that. Let's try to draw the XY line using normal line. I mean the reference line. So immediately let's try to name it. So switch on the caps and name it X, Y, and also name it VPHP. So let's try to name it VPHP. The next thing what you'll have to do it is using a visible line, draw the pentagonal pyramid base. There is a pentagonal shape base on the top, on the first stage of the top. So first draw a line and then leave your mouse and then just use your keyboard. So length tab 0 enter. That's what we'll be starting with. So length is 25. So 25 tab 0 enter. 25 tab 72 enter. 25 tab 144 enter. 25 tab 216 enter. 25 tab 288 enter. Later what you can do it is select that. Before even doing that, let's try to draw the center lines. So to obtain the center, we'll have to draw the diagonal line. So from the midpoint of each edge, draw a line such that it connects to the opposite corner. So from this edge, when you just place the cursor on the midpoint of that, you get this indication that is, it indicates that is the same midpoint. So from here, let me try to draw a center or joining to this corner. Similarly, from here, let me try to draw an edge joining this corner. Similarly, from here, from each edge, let's try to draw a midpoint joining the opposite corner. So let me try to do that. Now what you can do it is see that you are joining it correctly. So from here, similarly. So I've just drawn around each corner. You can even check it out once. So it seems correct. So now next thing what you can do it is go to trim and try to trim off the lines that are at the midpoint, joining the midpoint. So let me trim only those lines. So we have got this now. So now what you can do it is, okay, before even doing that, it's even important that you have to rotate that I forgot to do that. So you can do it now also, that's not a matter. So you can try to rotate that. So go to rotate and see that you are trying to rotate it such that it rests on one of its corners, because this problem is basically, the type of solid that is used in this problem is a pyramid, and the shape is pentagonal shape, and its resting position is on its corner. So see that you will have to do it before even drawing the diagonal lines, but I have done it, that's not an issue. So you can try to place on the extreme right side, a corner has to be there. So this corner has to be there on the extreme right side. So that let's try to rotate this. So let me try to use this edge to rotate. So let's take any one point as the fixed point or the center of rotation, and the other point to rotate from. So let me try to fix this point as center of rotation. Let me rotate from this point. You can try to rotate such that it's straight, or you can try to give the rotation angle here as 90 degrees and see that the copy is switched off, and try to enter. So just click it, just left click it, and you will get that. So you can select that again, go to move, and see that you are trying to move it separately somewhere here. So now this is this problem. So this is fine now. So now what you can do it is next is do the naming. So naming is very important. So let's try to name that. Let's try to name this A, B, C, D, and E. As you all know, in a pyramid, only the base will have a true shape. It all joins to an apex. That's a point. So then, at the top you don't have any shape. So only the base will be named. Next, using a normal line, let's try to draw projections up to this XY line. So from each point. So I've just joined it. and even the center has to be named here. So let's try to name the center as O01. So O is the center of this base and O1 will be the apex. So now from the center, let's using the center line. So let's try to draw the using center line. Let's try to draw it. I mean, the axis length is given as 50. So 50 enter. Let the angle be 90. So we have just joined that. So now go again to line, visible line. See that from its. So from here. I mean, let's try to join at every point. So, and even from here, let's try to join a line. So now we have got that. So now what we'll have to do it is do the naming for the front view. So the first stage of the front view. So once you can check it whether if it is correct or not. So suppose if any lines are not so correct, here I think two lines aren't so correct. So what you can do it is you can try to delete that one particular line and try to redraw it, or else you can try to redraw it because sometimes it might come wrong. You might get it wrong. So you can let's try to zoom it and try to draw it also, so that you will get it much better. So first go to center line. So from here you can even zoom it even more better. Yes, so from here, so let's try to give the the axis length as 50, enter. So we have just given the axis length as 50. So immediately change it to visible line. So see that, let's try to using this alignment indicator. So just join a line till here. Similarly till here. And that alignment indicator shows up till here. And similarly from here, let's try to join a line. So now it looks a lot better. So let's try to zoom that again and let's try to do the naming. So if this is A, the okay, I've just done another mistake. That is, as you know, this is not a prism, so this is a pyramid. So this has to be a pyramid. I'm sorry. So when it's a pyramid, all have to join to a apex. So that is very, very important. So see that don't repeat such mistakes. So even if you're doing, see that you try to immediately rectify that mistake. So let's join it to an apex. So just from all points we have just joined it to an apex. So that is very, very important. So now let's draw mention those points in the front view. So if this is A, in the front view this will be A dash. If this is B and E, B will be, the observer will see from here, therefore B will be visible, E will be hidden. So therefore B dash, and within the brackets it will be E dash. Similarly here it will be O dash, and even that O dash actually, as that is the center, so as when viewed from the front view it will actually be hidden. So O dash will be mentioned in the brackets, and here C dash will be visible and D dash will be hidden. So similarly this will be, the apex will be O1 dash, O1 dash, and even that O1 dash, and that is O1 dash, so that's fine. So that will be visible, so that is fine. Now let's try to, and what we can do it is using move command. You can try to place everything, as we have already zoomed it. We can try to place everything neatly. That will complete the first stage of this problem. So let's try to move it correctly onto some appropriate position, so that it looks much better and neater. Okay, now let's proceed on to the second stage of this problem. So in the second stage of this problem, they are telling the problem is, it is inclined to HP. Okay, such that the, you can just see rests on HP on one of its corners of the base, such that the two base edges containing the corner on which it rests makes equal inclinations with HP. Okay, draw the projections when the axis of the pyramid is inclined to HP at 40 degrees. Okay, they are telling the axis of the pyramid is inclined to HP at 40 degrees. So that is very, very important. So let's try to select this. You can try to select that. Yes, we just got it. You can try using this control key also from the keyboard. So let's try to, see that the copy is switched on. Let's try to pick from this corner. Let's try to pick and place it here. So that is very, very important. Now what we'll have to do it is go to rotate. So go to rotate and try to select this completely here. So now let's try to keep this as the center of rotation, and then let's try to rotate from here. So when you're trying to rotate from here, we'll have to give the rotation angle actually. So already they're telling it is inclined to HP at 40 degrees. So when you're giving the rotation angle and when you're trying to rotate from this point, so in prisms we were trying to rotate at this point, so but that was parallel, but here it is inclined, so you can't do that. So when you're trying to rotate from this point, we'll have to minus the given angle with 90 degrees. So 90 minus 40 will be 50. So give the rotation angle as 50 and just enter. And now you can even cross check it by measuring the angle between here, the axis and this, and that is found to be 40 degrees. So that is clear. So what you have done is also correct. So next thing what you'll have to do it is go to move option, see that the copy is switched on, and just move all those points. So A dash, B dash, O dash, and C dash, and this one will be O1 dash. Next thing is go to normal line. So from A dash to A, a line is drawn, and similarly from B dash to B, another line is drawn, and from E dash already a line is drawn, a vertical projector is drawn. So let's try to draw the horizontal projector and try to complete that. From O dash to let's try to draw a vertical projector. Already a horizontal projector is drawn here. So from C and D dash, let's try to draw a vertical projector such that let's try to join it here. So from C dash to C. Similarly from D, let's try to draw it and a horizontal projector and make it here. So now what we can do it is go to move option, so that a copy is switched on, and try to move all these points. So from A dash to A, and this will be A. So from B dash to B, and this will be B. From C dash to C, and this will be C. From D dash to D, and this will be D. And from E dash to E, and this will be E. So we have got 5 points: A, B, C, D, and E. So and next is O1 dash, O dash. I'm sorry, O dash to O, and that will be O. We can't move it. We'll have to type it. So that is O. So now let's try to zoom it. Before even zooming it, we'll have to confirm which will be the another projector that is here, that is from O1 dash. So from O1 dash to O dash. So this projector we forgot. So let's try to join that also as well. So now this will be O1. O1. So when the observer sees from here, wherever I've placed the cursor, that is this O1 dash, this face will be completely visible. Therefore, this O1 dash to C dash, D dash, so that one will actually be visible. And the endmost point is A dash. So A to the lines join coming from A, that is A to B, A to E, and A to O1, that one will be made hidden. So A to B, A to E, and A to O1 will be hidden. And when he sees from here O to C and O to D, O1 to C and O1 to D. So O1 to C and O1 to D, that one will be made hidden. And that one will be made visible, sorry. So that one, let's try to join that. So that one will be made hidden. Therefore O1 to C, when he sees from here, O1 to C and O1 to D will be visible. So O1 to C and O1 to D, let's make it visible. So go to line, go to visible line. So join O1 to C and O1 to D using a visible line. Therefore, next thing what you'll have to do it is join the boundaries. That is, the boundaries will have to be joined using the visible line. So therefore, O1E is at the boundaries, and E and D are also at the boundaries. Then D and C are also at the boundaries. C and B are also at the boundaries, and B and O1 again are at the boundaries. Next thing what you will have to do it is which one to be made hidden. You can just see this is the inmost point. So A to B, A to E, A to O1. That one will be made hidden. So A to B. So go to hidden line. Go to hidden such that increase thickness to 0.5. So you can even zoom it. A to B, A to E, B, E and O1. So B, E and O1 will be made hidden. So A to B is hidden, A to E is hidden, and A to O1 will be hidden. So before making it A to O1 hidden, so let's try to trim that and then let's make it hidden so that that overlapping can be avoided. See that the thickness is maintained at 0.5, so you'll get a better one. So A to O1. So now O to O1 has to be made a center line. So O to O1 already O to A, I mean A to O1 is a hidden line. So only from O to A1, O to A, only that one will be made hidden, such that no overlapping will occur. So center line O to A. So I think everything is done in the second stage. So I think that completes the second stage of the problem. In the third stage, so now we'll have to do it the third stage. The third stage will be quite simpler. So let's try to understand that. So in the third stage, they're telling it appears to be inclined to VP at 45 degrees. So whenever they're telling it appears to be inclined, there is nothing to worry. I mean, you are not going to find any apparent length or something here. So you're just going to continue with whatever they have given. So see that what they are telling us, they are telling it appears to be inclined. Draw the projections of the prism when the axis is inclined to HP at 40 degrees and appears to be inclined to VP at 45 degrees. I mean, this axis, that axis is inclined to VP at 45 degrees. So axis is O1. So that is inclined at 45 degrees. So what you can do first thing is go to normal line. So first draw a 45 degree line. So first draw a 45 degree line. That is very, very important. So let's try to draw a 45 degree line and let's try to measure that angle. So let's try to measure that angle, and that angle is 44.52. Let's make it 45 degrees. So after making it 45 degrees, let's try to zoom it. So let's try to zoom that. So let's try to pick from this point. So let's try to select this. You can select it like this, or else, as I told, using a control key also you can do it. See that all the major points are selected. Here you can see this O, that center is, that one we could not select here, the center of this prism. So see that even that line is also selected. But when that line gets selected, this entire projection gets selected. So what you can do it is go to split. So you can, let's try to split that. So split at this boundary. So now only this one could get selected. So you can just see now if we try to select it, only that one is getting selected. So let's try to move it. So let's pick from this corner O1 and just place it here. See that the copy is switched on, and just place that corner here. So we have just seen, I've just placed that corner over there. That's all. Now what you can do it is go to rotate. See that the copy is switched off. So pick from that same O1 and that O. Let that O1 be one point, another one like this. So like this, when you try to rotate it, it tries to rotate. So next thing what you can do it is go to select and select all these points, and you can try to delete that. You can even instead of selecting at a time, you could have even done it using control key, so that then if you are selecting using control key, you need not do this one like deleting these points now, because when you are doing it using control key, these points won't get selected. So see that you are trying to select these points and try to delete that. So now go to fit. Now just try to draw projection lines. Okay, before joining projection lines, it's important that we try to move these points. So go to move. See that the copy is switched on. So let's try to move these points. So A, B, C. So A, B, C, D, D, E, and O. So now we have just selected all the points. So now next thing what you'll have to do it is draw the projections. So go to normal line, draw projections. So first let's try to draw from here A to A dash. Similarly E to E dash and D to D dash, C to C dash is here, and B to B dash is here. And already we have just joined from A, B, C, D, E, and O, and similarly from O1. So O1 to, let's try to draw to O1 dash. So O1 dash is here. So now let's try to move those points. So, or else let's try to name it. So A to A dash. So therefore this will be A dash. And B to B dash is here. So this will be B dash. C to C dash is here. Therefore this is C dash. D to D dash is here, and this will be D dash. E to E dash is here, and this will be E dash. O to okay, we have just forgot to draw this one projection. So from here, so let's try to join from here. So it is the same projection with joints here. So this one. So this one will be O dash. O dash. So this one will be O1 dash. So let's try to move those. So I mean move it. I mean place it at a particular appropriate position. So see that the copy is switched off now. So this is D dash, and this is the same one will also be D dash, C dash. This will be E dash, and this will be O dash. So C dash is this. So see that you're picking it correctly. So this is C dash, and this is O dash. This is A dash, and this is B dash. So now this is A dash, B dash, C dash, D dash, E dash. So E dash is very important. So let me place it here. E dash, and this is O dash, and this is O1 dash. So now when the observer sees from here, wherever I've placed the cursor, now let me try to zoom it. So when the observer sees from here, from the down, so that means this face will completely be visible. That is A, B, C, D, E. So therefore A dash, B dash, C dash, D dash, E dash will be joined using a hidden line. And the outermost point here is, you can just see, and then the, what to say, the boundaries will actually be drawn using a visible line. So that one is, that's very quite common. And then O to E and O to A, that one will actually be made hidden. The reason for that is you can just see that is O1 is actually the outermost point here. So O1 to E, O1 to B, so that one, and O1 to A, that one will actually be made hidden. So the lines that is coming from there. So let's try to do that. So let's try to join that first. So first let's try to join this using a visible line. So let's try to do that. So go to visible line. So let's try to join these 5 points. A to B, A dash to B dash, C dash to D dash, D dash to E dash, E dash back to A dash. So let's try to do that. So we have just finished that. Next thing what you will have to do it is join those boundaries. So this is the boundary. and even this is one of the boundaries. And from there, so D and C we have just joined using a boundaries, and from there this is a boundary one, this is a boundary line, and similarly A dash to, there is also a boundary line. But okay, let's try to A dash and E dash we have not joined. So from B, C, D we have just joined it. So from A and E, how to join it? So as I told earlier, you can just see here clearly it is mentioned that you see this O1 is the outermost point. If the O1 is outermost point, O1 to E and O1 to A, that one will act, that one has to be a hidden line. So O1 to E and O1 to A, O1 to E in the sense, so this one, so O1 to E or E to O1, that one will actually be made a hidden one. So go to hidden, so let it be 0.5. So O1 to E and O1 to A dash, so that is hidden, so that one will be hidden actually, that will not be visible to the observer. And this one, so they both, so these two lines will actually be made hidden. So the final one what you'll have to do it is go to center line and join the center line. So that completes the problem. We have just done everything. See that you also make using the smart dimensioning distance between, indicate the dimensions also in every stage, first stage, second stage and third stage. I have not done it, but you can do that as well. That completes the problem. You can mention your USN and name at the end. So thank you so much. Take care. Bye. Hello all, welcome to this class on projection of solids. And